Yes, students, in last class we learned the concepts of logarithms and some examples. Today we are going to solve exercise 1.5 problems. So let us start. First, copy the first problem. So what is the first one here? Determine the value of the following. Here we have 9 problems. One by one I will solve. So first one is log 5 to the base 25. Log 5 to the base 25. So we have to find the value of this one. So which is in a logarithmic form, we have to change in terms of exponential form. So let log 5 to the base 25 will be equal to x, some x value. So if we change this into exponential form, how can you write? So 5 is equal to 25 power x. 5 is equal to 25 power x. Log n to the base a is equal to x means here a power x equal to n. So in last class we know that a power x is equal to n means here log n to the base a is equal to x. So which is nothing but a power x equal to n. So here 5 is equal to 25 power x. So next step, what we have to do, we have to write this 25 the exponents of 5. So 5 is equal to, that means we have to equal the bases. We can write 25 as 5 square whole power x, because 25 is 5 square. So 5 is equal to, here it is in the form of a power m whole power n. A power m whole power n is equal to a power mn. So 5 power 2x. So see here, 5 means 5 power 1 is equal to 5 power 2x. Here bases are equal. Hence exponents must be equal. So 1 is equal to 2x. What we have to find? We have to find the value of x. So yeah, 1 by 2 is equal to x. Therefore x equal to 1 by 2. So what is x? X is nothing but log 5 to the base 25. So log 5 to the base 25 is equal to 1 by 2. So what we have to assume? We have to take the given problem is equal to some x. And then you have to change that in terms of exponential form, and then you have to find out x value. So what is the second one? Log 3 to the base 81. So tell me what we have to take. Log 3 to the base 81 is equal to x. So if we change it in terms of exponential form, then 3 is equal to 81 to the power of x. What is the next step? You have to write 81 as the exponential of 3. That means exponents of 3. That means 81 can be written as 3 power 4 whole power x. So 3 is equal to 3 power 4x, because a power m whole power n is equal to a power mn. So here 3 means 3 power 1, which implies 1 is equal to 4x. So here onwards I will write implies. Implies means here bases are equal, hence exponents must be equal. So 1 is equal to 4x, which implies 1 by 4 is equal to x, or x equal to 1 by 4. What is x means? X means log 3 to the base 81 is equal to 1 by 4. So this two problems completed. The next third one, just copy it in your classwork. So third one is log 1 by 16 to the base 2. Log 1 by 16 to the base 2. So we have to take, let log 1 by 16 to the base 2 is equal to x, which can be written in exponential form as 1 by 16 is equal to 2 power x. So 1 by 16 should be changed as power of 2. That means 1 can be written as 1 power 4 by 16 can be written as 2 power 4 is equal to 2 power x. 1 by 2 whole power 4 is equal to 2 power x. Here we have 2 as base, here 1 by 2. So here I am changing this as 2 power minus 1 whole power 4 is equal to 2 power x. Y means here 1 by 2. That means 1 by a power minus n is equal to 1 by a power m. So using the concept of this one, 1 by 2 power 1 can be written as 2 power minus 1. So here a power m minus whole power n, a power mn. So based on that, minus 1 into 4 is minus 4 is equal to 2 power x, because a power m whole power n is equal to a power mn. So which implies here bases are equal, exponents must be equal, x is equal to minus 4, therefore x is nothing but log 1 by 16 to the base 2 is equal to minus 4. So all problems are similar type of problems. Next one, fourth one is log 1 to the base 7. Fourth one, log 1 to the base 7. Let log 1 to the base 7 be equal to x. So if we change it in terms of exponential form, then what happens? 1 is equal to 7 power x. So how to write 1 as a power of 7 means we can take 1 as 7 power 0, because anything to the power of 0 is 1. That means a power 0 is equal to 1. So 7 power 0 is equal to 7 power x, which implies x equal to 0. So therefore log 1 to the base 7 is equal to 0. In general, log 1 to the base a is 0. Log 1 to the base a is 0. So based on that concept also we can write, but the proof of this one is like this. So fifth one, here log root x to the base x. Log root x to the base x. Let log root x to the base x, for discrepancy, for convenient process, here I have taken p, because we are having the problem x. That's why I am assuming log root x to the base x as p. So if we change it into exponential form, root x is equal to x power p. So what is root x can be written as x power 1 by 2, because square root means here x power 1 by 2 is equal to x power p, which implies here bases are equal, hence exponents must be equal, p is equal to 1 by 2. What is p here? P is nothing but log root x to the base x is equal to 1 by 2. So very simple problem. Next, sixth one, log 512 to the base 2. Let log 512 to the base 2 is equal to x. We can write it as 512 is equal to 2 power x. 512 can be written as 2 power 9 is equal to 2 power x, which implies x is equal to 9. Therefore, log 512 to the base 2 is equal to 9. So, first we have to change the given logarithmic form into exponential form, and then we have to equate the bases, and then you have to find the values. What about next one? Next one is log 0.01 to the base 10. So this is the problem. Let us assume that log 0.01 to the base 10 is equal to x. So in exponential form it can be written as 0.01 is equal to 10 power x. So 1 by, here we can write it as 100 because if we remove the decimal we have 2 digits. So 1 by 100 is equal to 10 power x. We have to change this 1 by 100 in terms of power of 10. So 1 by 10 square is equal to 10 power x, which can be written as 10 power minus 2 is equal to 10 power x, because 1 by a power n is equal to a power minus n. So which implies x is equal to minus 2, because bases are equal, exponents must be equal, x is equal to minus 2. So therefore log 0.01 to the base 10 is equal to minus 2. What about next one? 8th one. Here, you have to copy all the problems in your classwork. 8th one, log 8 by 27 to the base 2 by 3. Log 8 by 27 to the base 2 by 3. So let log 8 by 27 to the base 2 by 3 be some x. So in exponential form, 8 by 27 is equal to 2 by 3 whole power x. Here I am writing 8 as 2 cubed by 27 as 3 cubed, because we have to get 2 by 3 as base. So that's why 2 by 3 whole power x. So here 2 by 3 whole cube is equal to 2 by 3 whole power x. Y means a power m by b power m is equal to a by b whole power m. So loss of indices, based on loss of indices which I have written in last class. So you have to recall all the formulae, then only you can understand easily. So here, as usual, we can write which implies means bases are equal, exponents must be equal, x equal to 3. What is x? X is nothing but log 8 by 27 to the base 2 by 3 is equal to 3. Next, the last problem here is 9th one. 2 power 2 plus 2 power 2 plus log 3 to the base 2. So all of you see here, observe. Here 2 power 2 plus log 3 to the base 2. Here 2 power 2 plus log 3 to the base 2. It is in the form of a power m plus n is equal to, we can write it as a power m into a power n. So what is a power m into a power n means here a power m 2 square into 2 power log 3 to the base 2. So here 2 square means 4 into 3. Y means, already we know a formula, a power log n to the base a is nothing but n. In last class we have written this formula. So a power log n to the base a is equal to n. So in using the formula 2 power log 3 to the base 2 is nothing but n, that means 3. So 4 3s are 12. So 12 is the answer for that problem. So I hope all of you understood problem 1, Roman 1. Yeah. First we have to change the logarithmic form into exponential form, and then you have to equate the bases, and then you have to find the value of x. So first Roman completed. Copy the second Roman problem. See the second Roman problem here. So listen carefully while I am doing the problems. You have to listen carefully and then copy. So write the following expressions as log n and find their values wherever possible. So here, second Roman, first one, log 2 plus log 5. So you have to recall all the formulae. What I have already told you, you have to memorize the formula, you have to learn the formulas and you have to memorize and you have to recall the formula and you have to use whenever it is useful. So log 2 plus log 5. What we have to express means we have to express in simplest form. So log n form you have to express and then you have to find the value of that one. So see all of you, log 2 plus log 5 can be, that is given, just write given log 2 plus log 5. Now see, it is in the form of log x plus log y. So assume that the base as 10, that is a common logarithm. If we don't have the base, then assume it as 10. So log 2 to the base 10, log 5 to the base 10. Here it is in the form of log x to the base 10 and log y to the base 10, which is nothing but log xy to the base 10. Because we know the formula log x plus log y is nothing but log xy. So log xy, which can be written as log 2 into 5 to the base 10. So which is nothing but log 10 to the base 10. Log 10 to the base 10 value is 1 because log a to the base a is 1. Already we know it. So what we have to do means we have to express this in terms of log n, that means simplest form. So here what I have changed this log 2 plus log 5 as log 2 into 5. Why means I know a formula log x plus log y is nothing but log xy. That's why log 2 into 5. Log 2 5s are 10. Log 10 to the base 10. Already I know it. Log a to the base a is 1. That's why log 10 to the base 10 is 1. So next, second one. Log 16 minus to the base 2. Here base is given. So log 16 to the base 2 minus log 2 to the base 2. If the base is not given, you have to take 10 as a base. Here base is given. So see here what given. The given value is log 16 to the base 2 minus log 2 to the base 2. So observe here it is in the form of log x minus log y. Log x minus log y is nothing but log x by y. Log x plus log y is nothing but log xy. Log x minus log y is nothing but log x by y. That is one of the formula. So we can write this as log 16 by 2 to the base 2. Log 16 by 2 to the base 2. So which can be written as 16 by 2 is nothing but log 8 to the base 2. Log 8 to the base 2, we can write it as 8 as 2 cubed. 8 as 2 cubed. So log n formula, we have expressed it in the form of log n. Now we are going to find out the value. So log 2 cubed to the base 2, because 8 can be written as 2 cubed. Because we are having base 2, so we have to change this in terms of exponents of 2. So 2 cubed means we can write it as 3 log 2 to the base 2. So y means log x power n means to the base a means n log x to the base a. So using this formula, we can write 3 log 2 to the base 2. Log 2 to the base 2 is nothing but 1. So 3 into 1, 3. Because log a to the base a is 1. So here you have to recall the formula and you have to use. So here first, once again I will explain here. It is in the form of log x minus log y. That means take as base a. So log x by y to the base a. So here log x by y is nothing but 16 by 2. So 2 8s are, so log 8 to the base 2. So we expressed this in form of log n, and then we are finding the value. So by writing 8 as 2 cubed, we got in the form of log x power n. So we can write it as log n log x. So 3 log 2 to the base 2. So log 2 to the base 2 value is 1. So the value is 3. Next, third one. So I'll copy these two problems. Okay. What is the third one here? 3 log 4 to the base 64. 3 log 4 to the base 64. All of you see here given 3 log 4 to the base 64. Here I am writing this as log 4 cubed to the base 64. Why? Log 4 cubed, because it is in the form of n log x to the base a. So we can write it as log x power n to the base a. So just remember this formula. So log 4 cubed is nothing but log 64 to the base 64. So we expressed this in terms of log n. So now what is the value of this one is 1. Why? Log a to the base a is 1. So we have to express the given one in terms of log n, and then we have to find the value. So what is the fourth one? So here see the fourth one. 2 log 3 minus 3 log 2. All of you see here, first write the given 2 log 3 minus 3 log 2. Just change the form. So here we can write it as log 3 square minus log 2 cubed. Why? Why means because n log x is nothing but log x power n. So log 3 square means log 9 minus log 8. So log 9 minus log 8 can be written as log 9 by 8. Log 9 by 8, because log x to the base a minus log y to the base a is nothing but log x by y to the base a. So we know the formula. So log 9 by 8. So here, see the third one here. What is the third one? Log 3 log 4 to the base 64. We can write it as log 4 cubed to the base 64. So we will stop here. Log 9 by 8, because we are unable to write this in terms of log 3 square and 2 cubed. So no need to find out the value of, we can't express it in terms of simplest form, because we have the base as 10 because it is not given. So we can't express it in simplest form. So leave as it is. So just we are expressed the given one in terms of log n. So see the next one. What is the fifth one here? Given that log 10 plus 2 log 3 minus log 2. So all of you see the blackboards here. Log 10 given, first you have to write. So log 10 plus 2 log 3 minus log 2. First I am writing log 10 plus log 3 square minus log 2. That means it is in the form of n log x. So we can write it as log x power n. We know the formula, so already you know it. So log 10 plus log 3 square is nothing but log 9 minus log 2. So all of you see here, log x plus log y. What is log x plus log y? Log xy. So log 10 into 9 take the base as 10, as already I told. If it is not given, we have to assume that the base as 10 because it is a common logarithm. So minus log 2 to the base 10. So now log 10 nines are 90 to the base 10 minus log 2 to the base 10. It is in the form of log x minus log y. What is log x minus log y? Log x by y. So we can write it as log 90 by 2 to the base 10. So log 90 by 2 is nothing but 245. So log 45 to the base 10. So we express the given in terms of log n. So log 45. So no need to simplify this because we don't have the same base. That means 45 to the base 45. Then you can write the value of that as 1. So no need to simplify here. So we have to express the given in terms of log n. So we express it in terms of log n. So the second Roman is completed. Hope you all understood. So students, repeat the video and listen carefully if you are not able to understand. Next, the third Roman. All of you copy the third Roman problems in your classwork. So hope you are all having textbooks. So those who are not having textbooks, we are giving a photo of exercise 1.5. So you have to see while I am reading the problem. So third one, evaluate each of the following in terms of x and y if it is given. So here third one, given that x is equal to log 3 to the base 2 and y is equal to log 5 to the base 2. So each one we have to find out log 15 to the base 2. So first we have to find the log 15 to the base 2. So we have to express each term, each one in terms of x and y. X and y. So what is x? Log 3 to the base 2. And what is y? Log 5 to the base 2. So for this to solve, first we have to change the given in terms of log 3 to the base 2 and log 5 to the base 2. So can we able to write this log 15 in terms of log 3 and log 5 means yes. Why? How? We know that log 3 into 5 to the base 2 because 15 can be written as log 3 into 5. So we have to express it in terms of log 3 or log 5. So log 3 into 5. So all of you know that log x into y is nothing but log x plus log y. So we can write it as log 3 to the base 2 plus log 5 to the base 2. What is log 3 plus to the base 2? It is x. What is log 5 to the base 2? It is y. So therefore log 15 to the base 2 is nothing but x plus y. So we have to express the given one in terms of x and y. So it is x plus y. Next, second. The second one is log 7.5 to the base 2. All of you see the blackboard. Log, this is given log 7.5 to the base 2. Here I am writing this 7.5 as 15 by 2. Why? Because I know 7.5 can be written in terms of 15 by 2. So 15 by 2 is nothing but the value is 7.5. So why I have written like this means log 15 to the base 2 minus log 2 to the base 2 because we know that log x by y is nothing but log x minus log y. So log 15 to the base 2 already we know how to write it. So log 3 into 5 to the base 2 minus log 2 to the base 2. So which can be written as log 3 to the base 2 plus log 5 to the base 2 minus log 2 to the base 2. So here all of you see how I write this means log x into y. Log x into y means log x plus log y. Log xy is nothing but log x plus log y. So now log 3 to the base 2, we know it as x, plus log 5 to the base 2, we know it as y, minus log 2 to the base 2 is 1. So because log a to the base a is 1, so therefore log 7.5 to the base 2 is equal to x plus y minus 1. So students, hope you all understood. So what we did here, 7.5, we have written it as 15 by 2. So because we can write 15 as 3 into 5, because the given one is x is equal to log 3 to the base 2 and y is log 5 to the base 2. Next, copy these two problems in your notebook. Next, third one is log 60 to the base 2. Here I will do log 60 to the base 2. So I want the first one, we have to write the given log 60 to the base 2. All of you, 60 we have to express in terms of 3 and 5. Is it possible? See here, I am doing 3 20s. So it is not divisible by 3. So here I am writing with the 5 4s. So 2 2s. So here I am writing log 60 as log 3 into 5 into 2 square. So 3 into 5 into 2 square to the base 2. Why I have written like this means here see 60 can be divisible by 3. So 3 20s and 20 is divisible by 5 4s and 4 is divisible by 2, so 2 2s. So we can express in terms of 3 into 5 into 2 square. So here log 3 plus to the base 2 log 5 to the base 2 plus log 2 square to the base 2. All of you, why I have written like that means we know that log x, y, z. Log xy is equal to log x plus log y. Log xyz means log x plus log y plus log z. So log 3 to the base 2 plus log 5 to the base 2 plus 2 log 2 to the base 2. So log 3 to the base 2 is x, log 5 to the base 2 is y, plus 2 into 1, log 2 to the base 2 is 1. So x plus y plus 2, x plus y plus 2. So that is the solution for that problem. Next problem, see your textbooks, log 6750 to the base 2. Shall I rub? Yes. Copy all the problems in your notebook. Log fourth one, log 6750 to the base 2. So as already you know, the 6750 can be written in terms of can it divisible by 3 or 5 or 2. We have to see. So now I will try for 3 6 plus 7 13, 13 plus 5 18. So it is divisible by 3. So 3 2s are 6, 3 2s are 6, 3 1 remainder, 3 5s are 15, 3 zeros. Is it divisible by 3? So 2 plus 2 4, 4 plus 5 9. So 9 is divisible by 3. Hence the total number is divisible by 3. So 3 7s are 21, 1 remainder, 15 is 3 5s 0. Is it divisible by 3? 7 plus 5 12. So 12 is divisible by 3. So we can write it. So 3 2s are 6, 3 5s are 3 zeros are. Is it divisible by 3? 2 plus 5, 7, 7 plus 0, 7. 7 is not divisible by 3, hence we have to look for 5. So 5 50s, 5 10s, 5 2s. So students, given what is given here, log 6750 to the base 2. We can write it as log, see, 3 cubed. 3 into 3 into 3. 3 cubed into 5 cubed into 2 power 1. So, have you understood? So, log 3 into 3 into 3 means 3 cubed. 5 into 5 into 5, 5 cubed into 2 power n. So, 6750 can be written as 3 cubed into 5 cubed into 2 power 1. So, it can be written as log 3 cubed to the base 2 plus log 5 cubed to the base 2 plus log 2 power 1 to the base 2. Why? Because log x, y, z is nothing but log x plus log y plus log z all to the base a. So now if you see, it is in the form of log x power n. Log x power n is equal to n log x. So we can write it as 3 log 3 to the base 2 plus 3 log 5 to the base 2 plus log 2 to the base 2. Now see, 3 log 3 to the base 2 already we know it as x plus 3 log 5 to the base 2 as y because we know it, the value is y. So log 2 to the base 2, 1. So 3x plus 3y plus 1. So therefore log 6750 to the base 2 is equal to 3x plus 3y plus 1. So hope you all understood. So this problem. So log 6750 to the base 2 is equal to 3x plus 3y plus 1. So Roman 3 completed. We will go to Roman 4. Copy the problem. So students, we will discuss the next problems in next session of the class. Thank you.